covered this morning a lot of different potential uses of BIM. And we have seen and tried to see how this could expand beyond just the design stage into the construction stage, into the operational stages of a building. Now, these slides will be available for you to do part of this work formally when you're actually designing your BIM execution plan. The BIM execution plan is a framework that you define that makes clear what people are supposed to produce at what moment in time during the development of the design. But a big difference will be made on those requirements as a function of what you hope to achieve with the data. So different data will be attached to the different semantic element as a function of what you want to get. So if structural analysis is in the scope of your BIM execution, you'll want people to specify loads of elements and work and you know, the weight and so on. If it's not, you can save money by taking that information out of the BIM model, for instance. Now, when you do that, you can think of a revolutionary approach in a sense, something that radically changes the dynamics of the interaction between players. However, it's always useful to start from the process that is as it happens today. So things, how they work today, and you can think of that, and then you can think, oh, what can be improved on this section, and this section. So this framework here, I think, helps you identifying those aspects and those dynamics. And this is a procurement process laid out in a schematic view, where you have time on the vertical axis and different players on the horizontal axis. So you have clients, designers, contractors, the industry as in the broader, the industry as an overall third parties provider and so on. And then you have all the other authorities, so councils, regulations, and so on. So in the scheme, you can see what is happening at each moment in time. And these lines provide you information about who's influencing what and what are the communication flows that work along this time frame. So it's, I mean, I won't cover it extensively right now, but it's important that you start understanding that these are things that you can analyze, and indeed you should probably be analyzing when you're defining a building information modeling execution plan. But you will not have to be constrained by this. So this is a traditional procurement method. Building information modeling could see drastic changes in the interrelation of this. So you can feel free to really revolutionize it, but it's good to know that these, you know, the events that happen there would probably still need to happen, even if in a different way. So you start from the objective, the definition of the objectives of the project, definition of an outline brief, and at some point some guidance comes in between the client and the design team, and then you see preliminary layouts that are influenced by regulations, and then you have some economic experience from the contractor that comes in to define both the site selection and some the feasibility of, in terms of costs and technology. A better brief is produced, and then you move to the next stage when you move to the schematic design, and you start working on layouts. The industry produces some product innovation in that stage, so you have new ideas, and the industry sometimes react, providing new technologies or new ways of implementing or improved costly improved elements and so on and so forth. And these are start to have a play in the layout situation here. Program planning, master cost plan, again economic experience for contractor is used there. cost-benefit evaluation of the scheme design, consent request documents are produced, and there you go to the statutory consent from the relevant authorities. You come back to technical investigations, and then again product innovation as an input, special design support is validated, and you go through this detailed design with where things have moved from the client focus to design and contractor focus, or design and industry focus, if you like, want to say it like that. But again, this is the traditional method. Life cycle planning for the whole of the thing, bill of quantities, and again, this is now becoming a rather old scheme. So the changes might have been, might probably be needed for this. But you can then go on to tendering, and you see all the documents and the selection of the contractor and so on. Construction stages, and here is everything happens. There's a big explosion of things happen around the site operations and control activities. You have product document, product delivery, on-site inspections, working quality record and reporting, design variations, on-site inspections again, blah blah blah. Construction moment is probably the most complex in terms of what's going on, because it involves substantial costs, and so the amount of control that people want to have over that is important. And then all of a sudden everything relaxes, and you have a completion and commissioning, you have the final permits and authentication of whatever has been built by the authorities, and from now on you have just a couple of lines. Maintenance. Easy. You're playing for the maintenance. And you have some maintenance activities, and you have some post-occupancy evaluation. It sounds nice. These 3 lines could, if you look at them from a different perspective and you cut through all of this from a cost point of view, could actually be 95% of the overall costs for the industry. So you could actually play with this scheme in a completely different way, classifying activity by relevance in terms of value, relevance in terms of cost, relevance in terms of innovation, and so on, and focus on your building execution plan to improve some of these aspects or all of these aspects as a function of what you consider to be most interesting to you. So you will have this slide, and you can probably start playing with it to have a generic starting scheme for the revolution that you are going to be suggesting or advising to the BIM team. Now, traditionally we call this area of management value management, design management again, and we have contract management on this side and construction management on the other side, and then you have facility management that completes that. So these are the areas of the traditional areas of management that are involved. But if you start looking at design and build situation, design and build for whoever done, do you all know what design and build is? You do? You do? You don't?
I
Okay.
guess so.
So the traditional procurement mechanism is the one whereby you complete a design for a building, and then you produce some documents that help the contractor give you an idea of the cost. Okay? Then they give you their estimate or their quotation, and then you select the contractor on the basis of that. Then you decide, you select one, and they start building. Okay? Design and build is a different pattern whereby you only produce an outline design of your requirements. So you define the specifications of what you want to achieve, and you've set some constraints about it. Then you just ask for contractors on non-completed designs, and you ask contractors to provide you a complete design and the cost for you. So what is the benefit of this for you is that the time frame is reduced, you get to use multiple designers, and you can also select the design that fits best your initial briefs, and you will be given the option between multiple design options. The benefit for the contractor is that they will produce a design that that maximizes their knowledge. So if you are a contractor that is very strong on steel structure, you'll put in a lot of steel structure and make a lot of profit from them. And you know that you have control of that technology, you're good at it. So you get benefits from either side. Another potential benefit is that if the design does not need to be fully completed before you appoint a contractor, you save some time, and the contractor can start building the foundations and some portions of the work before they have the full design, because they already know that maybe the doors have not been selected completely yet, but they know they will have time to do that as they start working. So time frame is shorter. Yes?
You mitigate risk as well. But that is more so.
Well, I haven't covered that yet, but yes, absolutely. Well, you say you mitigate risk. I would say you have a different risk balance between client and contractor. So the pricing of the solution that the contractor offers can follow different schemes, but one of the scheme is fixed amount. So the contractor takes up some more risk that they would traditionally take, because they know that they have some freedom in detailing the final design. So they take some ownership of the project. They know what their boundaries are in terms of brief, but then they can take up more risk because they are more empowered in the design stage. So in this sense, it changes the balance of the partners involved, and the areas of management traditionally used change, and there is a major change in how the contracts are managed. It's very easy to read in the slides. It says value and contract management on the left, and it says design, cost and construction management on the right. Okay, so this is design, cost and construction management as one integrated activity. This is still facility management. This is value, design, and project management. So that's where you set the top level benefits of your project, and you compare those with costs and time. We probably only have 10 minutes, so I'll skip some slides, but you'll have them on papers. Or I'll probably go very quickly through them. So pre-BIM, so before building information modeling came to be available, there was still the need to coordinate all of these activities in exchanging documentation about the building. And a number of sources have been established to do that. Standards have been defined to transfer information. Okay. Now, very often this would be through digital drawings rather than building information models. But the problems are still similar. So these are some of the sources that I can point you to that will include how this was standardized before BIM. But the idea is that, and the benefit that we still want to achieve through BIM-enabled solution is to go through, and through our building information management plan, execution plan, is to provide practical guidance to all the people involved so that they know what is expected of them to achieve the benefits that are intended through the use of information technology. And in the past, the desire of use cutting-edge technology was kind of restrained by the fear that
this would result in uncontrolled behaviors. What the industry has currently noticed is that we are facing a recession and we are facing big financial problems in the industry, and this results in removing some of those fears in favor of embracing more risk to be more profitable and therefore beat the market. So these product information management strategies is 2003. The problems are still there, but they kind of stated that they would probably need servicing after 5 years. It never happened because then BIM started to pick up and they say, well, whatever, this is going to die anyway. And people involved are these people. People involved are all sorts of people involved in Confederation of Construction engineers, quantity surveyors. You might not know what quantity surveyors are. Do you?
Yeah.
Do you? Sorry? Okay, you do. Because sometimes, quantity survey in Italy, we have no such thing. We don't know what quantity surveyors are. We don't need them anyway. You can think of a life without quantity surveyors. Trust me. Architects and so on. So, and they were more worried about the documents than about the technological interoperation. But the topics that you will have to cover in your building execution plan will still be the same. And it's how to exchange these ideas of what is contained into into the physical description of our elements, and what are the properties of the product that we intend to use. These are the two main areas of problem that we still have to deal with. And what they solved it in the past by giving you drawing guidelines and defining and separating your design in assembly drawings, so drawings that will bring together other references, and component drawings that will be pulled in as external references. The problem we're now facing is that by nature, the process of the procurement process is step-by-step evolution of subsequent approximation progressively closer to the final precise information that you want to deliver. So by nature, a BIM model, even if it appears to be complete, and we kind of mentioned this quickly this morning, will contain a lot of information that is there only by default, only because that's what the software developer considered to be the standard option for everybody. So there is a lot of worry in the process that information that will be taken for granted is actually not being kind of checked by the relevant professionals. And so in the past years, the model progression specification pattern was developed. And this is the idea that some details are only conceptual, even if they look completed, because a building information modeling application will do everything for you. And some other drawings will be approximate in geometry, which means they are likely to be final, they're likely to be close to the final requirement, but they are not yet. Only at stage 300 will be considered completed. Now we are sure that this is the geometry that we want. And later on you will say, okay, now not only the geometry is finalized, but it's ready for fabrication, which means that all the problems behind all the interaction of the elements is sorted. So it's not only the geometry that we want, but we can guarantee that it carries the required standards of acoustic insulation, thermal insulation, mechanical resistance, color, finishing and everything. So it's ready to go to production. Okay. Still, stuff might happen. So after you start on site, and even if you wanted to do and to build something that was according to the specification at LOD 400, I think a nice way to put it is that shit happens, stuff change, and at completion, upon completion, you can actually produce the design, the drawing of what was actually built, regardless of what we intended to build at fabrication level, because things might change. Now, in the file folder that you'll be given, there is a pointer to this idea of what is actually connected to all of these levels of detail. That's a good starting point for you to start thinking about the progression of a building information model from across functions. So you have a description of what is expected to provide multidimensional scheduling, so 4D planning, when we are at level 100, when we are at level 200, when we are at level 300, and so on. So you can start thinking what we want out of this function at this stage. And not only that, but you can start thinking of what you want out of specific elements at each stage. So if you want to cater for planning at level 100, you, for an interior wall, cost and other information like that will just be taken roughly with an idea of per square meter. So you know that walls are generally whatever, 100 pounds per square meter of building. That's an acceptable level of detail at 100. But if you want to move up to level 200, then you start to have some idea of where the geometries should be with a nominal thickness, but you don't go in detail what are the layers in between. That's not interesting yet. Properties such as cost and so on might be included as a range. So you start saying, well, at this point you must tell me what is the price range that is expected from a contractual perspective. So each wall will be £50 per square, well, from 50 to 60 square pound per square meter. Okay? So you start thinking of a kind of precision. As you go on, you go, you refine this detail, and all of this is now authoritative. Okay, it means that this is the final bit of information. At the end, you want the actual installed wall model with all the exact cost that it costed to you to put there, maybe to the provider to put to transport, and so on and so forth. Different information can be specified for a duct run. So you can actually go and classify and specify and mandate requirements for different types of objects. Okay, and there are Excel files that help you with some templates, help you with some boilerplate solutions. And there is one here that you can have a look at. I'm waiting for Peter Barker to come in any minute. Say again?
That was Alex.
Yeah. So, let's try to move even forward. I think I'll cover integrated project delivery in a later session. We don't have enough time to start on that topic now. But I wanted you to start thinking broadly about what is current use of information technology in the construction, and what could be a vision that you aim at achieving strategically in 5 to 10 years' time. And to do that, I will point you to an European research that was run a couple of years ago, that was called RoadCon, which is a roadmap for the development of construction IT. This is a set of statements on different topics that they recognized to be current a few years ago, in the half of the past decade. Is that what you say? 2004? Yeah, mid of the past decade. 10 years. And they had a vision for what is coming in the next 10 years from now. So, theme by theme, they say, well, okay, what's the status of information access today or 5 years ago, and what is the status of teamwork today, and what's going to be in some time. So, in terms of document-based ICT, they say currently the creation and sharing of human interpretable information is what we have. So it's humans interpreting information. In the future, model-based ICT will enable application integration, automation, simulation, visualization based on computer interpretable data. This is what we've been talking about this morning, is the ability of a computer to do something about those things. Without, and the big thing is, without human intervention. Okay, just what we said about the possibility to have automated building compliance checks from the council. So in terms of legal, contractual governance, we are expecting that blah, blah, blah. And you can read this, and I will point you to a really, really, really thick document that you can go through. I think you have probably lots of reading to do in the next few weeks. What we'll be covering in the next few days is mostly the idea of collaboration, flexible interoperability, and ways to achieve that. My personal interest is connected with knowledge sharing, because we have seen how important it is for us to improve the quality of the information that you have as a level of detail. But what happens when you start a new project? Do you go back and start from scratch? Or can you find a way to archive the wealth of information that you have accumulated with previous projects in order to improve the behavior that you will have in subsequent projects? Learn from your mistakes. Have computers signal to you and acknowledge when there is a problem that you haven't foreseen. Data mining, model sharing, collaborative and cooperative knowledge management. That's a big, 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 big thing. So what is the information that we can share, and what is the information that we should retain? There are, of course, problems with skills and awareness, because you cannot hope to do that, and you know that because you wouldn't be here otherwise. You cannot hope to do that without people that have a deep understanding of what building information modeling means and what are the benefits that it can deliver to the industry. And so on. And of course, one of them is total life cycle. So what are the boundaries? Where do we say that our project is complete? We've seen design and build as one of the options. So you give me the money, I will make the design, and I'll construct the building. I'll take some risk for it, but I will manage to be more efficient than my competitors. What if But what you're really interested in is not that. What you're interested in from a building is probably your life in the building. That you're going to have a quality of life in that building that you don't want to be worrying about that. So there are now tendencies to go further beyond design and build, and we are starting to see design, build and operate schemes where I, as a contractor, design a building, construct it for you, and then I give it to you to use, and what you give me is a monthly fee. And I will take care of keeping it heated for you. I'll make sure that it's technologically updated whenever it's needed, and so on. Why would I have some benefits in doing that? Well, because I know the building, I designed it, and I built it. So I can probably operate it, if I'm clever, better than you could. So there is room for efficiency gains in this. And if we have such an agreement, I could put in some initial investments into improving some technological aspects of the build, so that the running and operational costs will be smaller. All right? So, in a sense, you are now in front of a scenario where all opportunities are available. Exploiting the knowledge to increase efficiency. Yeah, Peter's here. Okay. Okay, so this is what I wanted to say today. Hello, Peter. Welcome. And what Peter will cover now is probably how this really happens in the real world.